Ever wonder how your phone's camera instantly recognizes a cat in a photo, or how AI assistants understand your voice? It's all thanks to some pretty clever tech, like a groundbreaking method called LatHAdapter. Today, we're diving into how this innovation is helping machines think more like humans, especially when faced with new or ambiguous information. Let's unpack the science behind it. Traditional AI models, like those powering image recognition or translation, typically learn by directly comparing examples. Think of it as teaching a kid to identify a dog by showing them hundreds of dog photos and saying, "This is a dog." But what if you only showed them one photo? That's where things get tricky. That's where LatHAdapter steps in. Here's the breakthrough. LatHAdapter doesn't just memorize examples. It teaches AI to organize knowledge in a hierarchy, mirroring how humans group concepts. Imagine a mental filing system. Animals right arrow, dogs right arrow, puppies. This structure lets AI infer relationships between ideas, even when it's never seen a specific example before. But how does it achieve this? The secret lies in hyperbolic geometry, a mathematical framework that represents hierarchies in a curved, tree-like space. Picture an expanding landscape where each branch symbolizes a category, and proximity reflects similarity. A penguin, for instance, would cluster closer to birds than fish, even if it can't fly. This setup allows AI to model complex, nested relationships more efficiently than flat Euclidean spaces. Now, let's break down the magic behind LatHAdapter. It uses two key mechanisms to train AI. One, contrastive loss. This helps the AI distinguish between similar concepts. Think of it as a teacher saying, "A cat and a kitten are closely related, but a cat and a car." Not at all. Two, hierarchical regularization loss. This ensures knowledge stays organized. It's like enforcing a strict filing system. Dogs stay grouped, while penguins occupy their own branch. What sets LatHAdapter apart? Unlike other methods, it learns hierarchies directly from data, not predefined categories. It leverages attribute prompts, semantic tags that link broad ideas like animals to specific examples like puppies. This adaptability lets AI grasp new categories with minimal examples, a game changer for real-world applications. The results? In tests, LatHAdapter boosted performance by up to 4.68% in few-shot learning, when data is scarce, and improved accuracy across 11 datasets. Whether identifying rare species in images or decoding nuanced text, this tech is making AI more efficient and intuitive. So why does this matter? By combining hyperbolic geometry with smart hierarchy building, LatHAdapter is bridging the gap between human-like understanding and machine processing. It's not just about memorizing facts. It's about grasping connections, adapting to novel challenges, and mastering details with less data. But this is just one piece of a larger puzzle. AI's true power lies in its ability to learn from vast datasets, refining models through trial and error. Scientists test these systems relentlessly, teaching algorithms to analyze millions of scenarios, like a self-driving car processing road conditions in real time. The goal? To create technology that feels intuitive, almost human. The payoff? Smarter assistants, more accurate medical tools, and devices that adapt to our needs. It's not just about efficiency, it's about connection. AI is redefining how we interact with technology, making it more responsive, personalized, and dare we say, almost thoughtful. Next time you chat with a smart device, remember, it's the work of curious scientists turning abstract ideas into everyday miracles. Thanks for watching and keep exploring, because the future of AI is still being written and you're part of the story.